Hello there, and welcome back to the Sleepy Nova Chronicles. Tonight, somewhere in the dark outside a city you have never visited, a wolf is listening. Not moving, not hunting, just listening, its enormous ears rotating independently of each other, scanning two separate sections of the surrounding darkness simultaneously, processing the soundscape of a boreal forest at 2 in the morning with a sensitivity that would fill an entire room of human instruments to replicate. It can hear a twig snap at 3 kilometers. It can hear the difference between the footfall of an elk and the footfall of a moose at distances that would reduce either animal to a smear of color in your peripheral vision on the best day you have ever had in open country. It can hear, in the specific acoustic signature of the forest around it, whether the silence is the silence of nothing happening or the silence of something staying very still. Right now, the wolf has decided that whatever it heard is nothing. It lies down, in the dark, in the cold, in the specific, unhurried, deeply experienced confidence of an animal that has been the apex predator of the northern forest for 2 million years, and that has, in those 2 million years, developed a relationship with darkness and silence, and the cold night that is the precise opposite of fear. The darkness is home. The silence is information. The cold is simply the world as it is, the background condition of an existence that has been shaped by cold from its very beginning, that carries in the dense undercoat and the broad pores and the efficient metabolic architecture of its body the accumulated solution to every problem that cold presents. The wolf does not endure the night. It inhabits it. This is the misconception to release tonight. Quietly, without effort, the way the wolf releases its attention from the sound that turned out to be nothing. The wolf of the popular imagination is a creature of ferocity and threat. The big bad wolf, the lone wolf, the symbol of wild danger, the animal that fairy tales taught you to fear before you were old enough to question whether fear was the appropriate response. That wolf is real, in the sense that wolves are genuinely powerful, genuinely capable of killing prey many times their own size, genuinely the apex predators that their ecological role requires. But ferocity is not the wolf's defining characteristic. Intelligence is. Cooperation is. The specific, sophisticated, extraordinarily well-studied social architecture of the wolf pack, the network of relationships and roles and communication and shared memory and coordinated decision-making that allows a group of animals averaging 40 kilograms each to successfully hunt prey that weighs 500 to 800 kilograms, is the defining characteristic. The thing that made the wolf the most successful large predator the Northern Hemisphere has ever produced. The thing that allowed it to occupy a range, at its peak, that stretched from the Arctic to Mexico, from the British Isles to Japan, across every biome in the Northern Hemisphere from tundra to desert to temperate forest. The wolf succeeded because of its social intelligence, not its teeth. Wolves have been living in social groups for approximately 1 million years. The specific cognitive architecture of pack life, the capacity to track the relationships between multiple individuals simultaneously, to remember who cooperated and who defected, to coordinate complex collective actions through communication, to make and honor long-term social bonds, is not a recent refinement of wolf behavior. It is the core evolutionary innovation that defines the wolf as a species and distinguishes it from every other large canid that has ever existed. And that cognitive architecture is directly related to yours. Not metaphorically. Genealogically. The dog lying at the foot of someone's bed right now, or curled on a sofa, or sleeping in a basket in a kitchen, is a wolf. Canis lupus familiaris. A subspecies of the grey wolf, Canis lupus, separated from its wild relatives by approximately 15,000 years of domestication, but carrying in its genome and its neurology and its social behavior the deep wolf heritage, the pack cognition, the social bonding capacity, the communication repertoire, that made the original domestication possible. You domesticated the wolf because the wolf was already social in the specific way that a social primate could recognize and cooperate with. Because the wolf already understood groups, already understood hierarchy and alliance and reciprocity and the specific emotional signals, the tail positions, the ear orientations, the eye contact, the vocalization, that communicate social information between members of a cooperative group. Because when your ancestors looked at the wolf and the wolf looked back, both of them recognized, in the other, the specific thing they most valued in their own kind. Someone who understood how to live with other people. Tonight we are going to follow the wolf. From the mechanics of how the pack works, the specific social architecture that 2 million years of cooperative hunting built into the wolf's biology and behavior, through the communication system that allows a pack to coordinate without language, through the hunting strategies that allowed wolves to reshape entire ecosystems, through the long catastrophe of the wolf's relationship with human civilization and the extraordinary recovery that has followed in the last 50 years, to the place where all of it arrives in you, in the social cognition your brain shares with the pack, in the cooperative instincts your lineage developed in the same cold forests where the wolf developed its own, in the specific comfort of the group at rest that both species, wolf and human, have been feeling at the end of a long day for 2 million years of parallel evolution in the same dark, cold, demanding northern world. If this quiet journey into the life of the wolf is useful to you tonight, a slow hour of pack intelligence and howling communication and the ancient, cooperative, socially sophisticated life of the northern forest's most misunderstood apex predator, then I would gently invite you to subscribe, or to leave a thought below about which part of this stays with you. It helps other people who are lying in their own warm dark, also members of their own particular pack, also reaching the end of a long day of social navigation, find their way here. One howl at a time. But for now, there is only this. Allow your shoulders to soften. Let your breathing slow, not forced, not managed, just allowed to find the pace it finds when the body has finished its day's work and the group is safe and the territory is quiet and nothing in the immediate environment is asking for action. The pace of a wolf lying down at 2 in the morning in a boreal forest, its enormous ears still monitoring the darkness but its muscles finally, completely, releasing the tension of the hunt. The forest is quiet tonight. The pack is together. The wolf is listening, and everything it hears tells it the same thing. Rest. Let's begin. A wolf pack is not a hierarchy of dominance. This is the first correction that 2 decades of careful field research has made to the popular understanding of wolf social structure, a correction with consequences for everything that follows. The image of the wolf pack organized around an alpha male and an alpha female who dominate the other members through force and threat, who eat first and breed exclusively, and maintain their position through continuous displays of aggression that the subordinate members continuously submit to. This image is wrong. Not partially wrong. Wrong in its fundamental premise about how wolf social groups are structured and what holds them together. It was derived from studies of captive wolf populations. Captive wolves, unrelated individuals assembled from different geographic origins and forced to coexist in a confined space, do organize themselves through dominance and submission, through the assertion of priority access and the suppression of competitors. They do this because they have no choice. They cannot leave. They cannot form the social structure that wild wolves form, because wild wolf social structure requires something that captivity precludes. Family. A wild wolf pack is a family unit, typically a breeding pair and their offspring from the current year and the previous 1 or 2 years. The alpha male and alpha female are not dominant over subordinates. They are parents. Their authority in the group is the authority of parents, the same authority that experience and investment and the specific knowledge of a territory that a mature breeding pair accumulates over years of living in a place provides to any organism that depends on parental guidance for its development. The breeding pair lead because they know more, not because they are stronger, not because they enforce their position through continuous displays of force. Because they have been alive longer, have hunted this territory longer, know where the elk concentrate in winter, and where the river crossings are, and which rival pack holds the territory to the north, and how far that territory's borders extend. They carry the knowledge of the pack. And the younger wolves follow them because following the wolves with the most relevant knowledge produces better outcomes than not following them. The wolf pack runs on information, not fear. Detectives looking at wild wolf pack behavior using GPS telemetry and direct observation over periods of years and decades, the most comprehensive long-term field studies in the history of wolf research, conducted primarily in Yellowstone National Park after the reintroduction of wolves in 1995, revealed a social structure of extraordinary subtlety. The breeding pair coordinate the pack's movements and hunting decisions, but they do not do so unilaterally. Pack decisions, where to travel, when to hunt, whether to engage a particular prey animal or abandon the attempt, emerge from a process that resembles, more than anything else, collective decision-making. Individual pack members signal their readiness or reluctance for specific actions through body language and vocalization, and the pack's behavior reflects the composite of these signals rather than the unilateral decision of a dominant individual. The pack thinks together, not with any single brain as the headquarters of the collective intelligence, but through the continuous exchange of social signals between members whose individual assessments of the situation contribute to the group's emergent decision. This is the same collective decision-making mechanism we encountered in the honeybee colony, the distributed processing of information across multiple nodes in a social network, producing outcomes that no individual member could have calculated alone. The wolf pack and the bee colony are running the same computational architecture, in different species, in different environments, at different scales, because the architecture works. The social group that thinks collectively is more intelligent than the sum of its individual members. This is not a platitude. It is a measurable property of the specific information processing that happens when multiple individuals share their assessments of a situation through a common communication system, the emergent intelligence of the network exceeding what any individual node could produce in isolation. And the wolf's communication system, the specific, multi-channel, remarkably rich repertoire of signals through which pack members exchange social information, is the foundation on which that collective intelligence runs. The wolf communicates in at least 4 simultaneous channels: vocalization, body posture, scent, and touch. The vocalizations alone, the howls, the barks, the growls, the whimpers, the yips, the specific combinations of these sounds that constitute the wolf's acoustic vocabulary, carry more information than most people who have heard a wolf howl and felt its effect on their nervous system have any reason to suspect. The howl is not simply a territorial claim or a location broadcast. It is a complex signal encoding the identity of the individual wolf, its emotional state, its social status within the pack, and in some contexts its assessment of the immediate situation. Detectives looking at the acoustic structure of wolf howls using spectrographic analysis revealed that individual wolves have howl signatures as distinctive as human fingerprints. Each wolf produces a howl with a specific fundamental frequency, a specific pattern of overtones, a specific temporal structure, the rise time, the peak, the decay, that identifies the individual to any other wolf that has heard it before. A wolf that hears a howl from a kilometer away can identify not only the species and the approximate location of the caller, but the specific individual. Whether it is a pack member or a stranger, whether it is a wolf the listener knows or a wolf it has never encountered. The howl is a name, called across a cold dark forest at 2 in the morning, carrying its specific identity through the still air at the speed of sound, received by ears that have been tuned by 2 million years of natural selection to extract maximum information from exactly this signal, processed by a brain that stores the acoustic signatures of every wolf the listener has ever encountered. One wolf howls. The others know who is calling. Your own voice works this way too. The specific acoustic signature of your voice, its fundamental frequency, its overtone structure, its temporal patterns of articulation, identifies you as specifically to anyone who knows you as a fingerprint, identifies you to a forensic technician. People who love you can recognize your voice in a crowded room, at a distance, in poor acoustic conditions, from a single syllable. Your voice is your identity signal. It has been your identity signal since before you were born, since the fetus in the womb began learning to recognize the specific acoustic signature of its mother's voice in the sound environment it inhabited for 9 months. You have been identifying individuals by their vocalizations since before you could breathe air. As the wolf identifies its pack mates by theirs. The body posture channel of wolf communication is equally rich, a visual vocabulary of tail positions, ear orientations, facial expressions, and whole body postures that signal everything from playful invitation to dominance assertion to submission to anxiety to the specific, focused intensity of a wolf that has detected prey and is preparing to engage. Detectives looking at the wolf's facial musculature revealed that wolves have a muscle above their eyes, the levator anguli oculi medialis, that allows them to raise their inner eyebrow, producing a specific facial expression that looks, to human observers, remarkably like the facial expression humans produce when feeling sad or seeking reassurance. Dogs have this muscle. Wolves, in their wild state, have a rudimentary version of it. But domesticated dogs have developed it to a degree far exceeding their wild relatives, and they use it, researchers documented, specifically in the presence of humans. The inner eyebrow raise that the domesticated dog deploys when looking at a human is not a random feature of canine facial anatomy. It is an adaptation, selected over 15,000 years of domestication, that exploits the specific neural response of the human face processing system to an expression that triggers the caregiving instinct. The dog evolved a facial expression specifically to communicate with you. Not with other dogs. With you. With the specific emotional triggers of the primate face reading system that your lineage developed over millions of years of social living in groups, where reading the emotional states of other group members was a survival skill. The dog learned your language at the level of the face in 15,000 years. This is the monster of wolf and dog social cognition, not the strength of the wolf's jaws or the speed of its attack or the territorial aggression it displays toward rival packs. The monster is the capacity for social learning, the capacity to observe the signals that other species produce and extract from those signals the information that allows coordination. The capacity to be domesticated, to shift from a wild apex predator operating in a wolf pack social structure to a human household companion operating in a human family social structure, in an evolutionary eye blink, because the underlying cognitive architecture was already in place. The wolf was already reading social signals. When your ancestors looked at it and it looked back, both of them were doing the same thing, reading each other. Both of them social animals with large brains and complex communication systems and the specific capacity for forming bonds with individuals outside their immediate family group that the cold, demanding, cooperative hunting lifestyle of the Northern Hemisphere selects for in every species that attempts it. Both of them recognizing, in the other, a mind that worked like their own. The wolf pack hunts approximately 2 to 3 times per week in winter, less frequently in summer when smaller prey is more accessible and the energetic cost of the large cooperative hunts is less necessary. Between hunts, the pack rests. And the resting of a wolf pack, the specific, social, physically intimate resting behavior of a group of animals that have spent their evolution in cold environments where body heat is a resource to be shared, is one of the most carefully documented and most touching aspects of wolf behavior in the long-term field research. Wolves sleep together, not simply near each other. Together, in physical contact, bodies pressed against bodies, sharing warmth in the specific way that social mammals in cold climates have always shared warmth. A wolf pack resting after a hunt arranges itself in a pile of overlapping bodies, each wolf pressed against at least one other, the shared warmth of the group providing thermal efficiency that isolated sleeping could not. The pack reduces its collective heat loss by approximately 30% compared to sleeping individually, a significant energetic saving in an environment where the temperature regularly drops to minus 30 degrees Celsius. Minus 30 degrees Celsius. The temperature at which exposed human skin freezes within minutes. The temperature that the wolf's dense, two-layered winter coat, the soft, fine, insulating undercoat and the long, water-repellent guard hairs that together provide insulation equivalent to approximately a 7 centimeter thick layer of still air, handles without any physiological stress. The wolf at -30 is comfortable. Its resting metabolic rate does not increase significantly below approximately -12 degrees Celsius, the temperature at which the insulation of its coat provides sufficient protection without additional metabolic heat generation. The wolf is built for cold the way the deep-sea organism is built for pressure. Not resistant to it, adapted to it. The cold is not a challenge to be overcome. It is simply the world as it is, the background condition that the wolf's entire biology and behavior has been tuned to inhabit with the same effortless competence that a fish inhabits water. Your body resting tonight is doing the same thing the wolf pack does when it piles together in the cold, conserving the heat that your metabolism generates, maintaining the core temperature that your cells require, distributing the metabolic cost of warmth across the specific thermal architecture of a body wrapped in its covering in a sheltered space. You are sharing warmth with yourself. Your skin, your fat layer, your bedding, the warm air of the room, all of it working together in the same cooperative thermal system that the wolf pack uses, at a different scale, with different components, toward the same biological end. Core temperature maintained. Energy conserved. Rest achieved. The territorial range of a wolf pack varies enormously depending on prey density, season, and competition from neighboring packs. In the northern Rocky Mountains of North America, the landscape of the Yellowstone reintroduction that has produced the most detailed long-term wolf research in the world, individual pack territories typically range from approximately 150 to 1,000 square kilometers. 1,000 square kilometers. An area larger than the cities of London or New York within their central zones, claimed and patrolled and maintained against rival packs by a family group that typically numbers between 6 and 12 animals. 6 to 12 wolves. Managing a territory the size of a major city. They do it through scent marking, through the deposition of urine and feces at strategic points throughout the territory, on prominent landmarks, at trail junctions, on the edges of the territory where it abuts the territories of neighboring packs, building a chemical map of the pack's presence and occupancy that any wolf that enters the territory can read with its nose. The scent marks are not simply territorial warnings. They carry information about the identity of the marking wolf, its reproductive status, its health, how recently the mark was deposited. A wolf reading a scent mark is reading a document, extracting specific, encoded, biologically meaningful information from a chemical signal that persists in the environment long after the wolf that left it has moved on. The forest is a library, written in scent, read by noses, and the wolf that reads it, that moves through its territory reading the scent marks of its pack mates, and the scent marks of strangers, and the scent signatures of prey animals that passed through recently, and the 100 other chemical signals that the environment carries, is not simply navigating. It is monitoring the social and ecological state of its entire territory through a continuous stream of chemical data, updating its understanding of what is happening and what has happened across 1,000 square kilometers of landscape from the information encoded in the molecules that other animals have left on trees and rocks and patches of snow. The wolf knows its world in a way that no instrument can replicate, because the instrument is the wolf itself. Its nose, its memory, its capacity to recognize thousands of individual chemical signatures and retrieve, from memory, the contextual information associated with each one. The wolf that smells a familiar packmate's urine on a tree knows not just that the packmate was here but roughly when, and in what reproductive condition, and heading in which direction. The wolf that smells an unfamiliar wolf's urine knows that a stranger has been in its territory and needs to be investigated. Your own nose carries something of this legacy. Stripped back by the demands of an upright posture and a visual-dominant primate brain that devoted neural territory to color vision at the expense of olfactory processing, the human nose is often dismissed as the weakest of the human senses. And by raw sensitivity, it is. A dog's nose contains approximately 300 million olfactory receptors. A human nose contains approximately 6 million. But 6 million olfactory receptors is still an extraordinary instrument. Detectives looking at the capacity of the human olfactory system to distinguish between different scents revealed that humans can discriminate between approximately 1 trillion different odor combinations, a number that makes the visual system's capacity to distinguish approximately 10 million different colors look modest by comparison. You cannot smell a prey animal at 3 kilometers. But you can detect certain compounds at concentrations of a few parts per trillion. You can smell fear. The specific volatile compounds released in human sweat during acute stress are detectable by other humans and produce measurable physiological responses in the people who smell them. You can smell kinship. Close genetic relatives smell recognizably different from unrelated individuals, a capacity that operates below conscious awareness but influences social behavior in measurable ways. You are more wolf than your nose suggests. The pack is resting now. In the dark of the boreal forest, the 6 to 12 members of a wolf family are pressed together in a pile of shared warmth, their breathing slow and regular, their enormous ears still monitoring the darkness, but their muscles finally released from the sustained effort of the hunt. Their territory extends in all directions, 150 to 1,000 square kilometers of scent-marked, known, managed landscape. Their prey is resting too, somewhere in the dark. The forest is quiet. The cold is simply the world as it is. And the pack is exactly where it needs to be. Together, in the dark, at rest. Where wolves live, rivers run differently. This is not a metaphor. It is a direct, measured, field-documented ecological consequence that was first clearly demonstrated in Yellowstone National Park after the reintroduction of wolves in 1995, and that has since been confirmed in every ecosystem where wolves have been reintroduced or where their presence has been compared to ecosystems from which they have been removed. The wolves changed the rivers, not by engineering them, not by any direct physical intervention in the hydrology of the landscape, by changing the behavior of the elk. Before the wolves returned to Yellowstone, the park's elk population had been grazing without predation pressure for approximately 70 years. Without the constant awareness of predation risk that wolves impose, the elk could afford to graze in the most convenient locations, the valley bottoms and the riverbanks, where the richest vegetation grew and the terrain offered easy movement. They grazed those areas intensively, continuously, without the vigilance that the presence of a predator requires. And the riverbanks were stripped. The willows and aspens and cottonwoods that had grown along the watercourses were browsed down to stumps, unable to regenerate above grazing height. The root systems that held the riverbanks against erosion were weakened. The shade that the riparian vegetation provided to the water surface was gone. The beaver, dependent on the willows for food and dam material, had largely disappeared from the valleys because the willows were gone. The rivers ran faster, carried more sediment, eroded their banks more aggressively, wandered less in their channels because the riparian vegetation that normally holds riverbanks stable and allows the river to meander was absent. Then the wolves returned, not in large numbers. The initial reintroduction in 1995 involved 14 wolves, 14 animals, released into a park of approximately 8,900 square kilometers. 14 wolves, in a landscape of nearly 9,000 square kilometers of prey-rich, predator-free wilderness. And within a few years, the elk behavior changed. Not because the wolves killed enough elk to reduce the population significantly, though they did reduce it, because the elk became afraid again. Because the presence of wolves in the landscape reimposed the predation risk that had been absent for 70 years, and the elk, carrying in their biology the deep, evolutionary memory of wolf predation that had shaped their behavior for millions of years before the wolves were removed, responded to that risk by changing where they grazed and how long they stayed in any particular location. The valley bottoms and the riverbanks became dangerous. The elk moved. And in the places the elk stopped grazing so heavily, the willows and aspens and cottonwoods grew back. The root systems re-established. The riverbanks stabilized. The shade returned to the water surface. The beavers, following the willows, building their dams from the newly available material, returned to the valleys and began constructing the pond systems that their dams create. And the beaver ponds changed the hydrology further, slowing the water, spreading it across the floodplain, raising the water table in the surrounding soil, creating the wet meadow conditions that support the specific plant communities, that support the specific insect communities, that support the specific bird communities that had been absent from the valley bottoms for 70 years. 14 wolves changed the rivers of Yellowstone. This is what ecologists call a trophic cascade, the effect of a predator propagating down through the food web, not through direct predation but through the behavioral changes that predation risk induces in prey species, which in turn release the plant communities from the grazing pressure that had been suppressing them, which in turn allows the physical landscape to express the ecological potential that the absence of predation had been preventing. The wolf is a keystone species, not because it is the largest or the most abundant or the most ecologically numerous organism in the ecosystem, because its presence or absence determines the structure of everything below it in the food web. Remove the wolf. The ecosystem simplifies. Return the wolf. The ecosystem recovers. The monster of wolf ecology is this function: the capacity of a single predator species, present in low numbers across a vast landscape, to regulate the behavior of prey species across that entire landscape through the mechanism of predation risk, and through that behavioral regulation to determine the structure of the vegetation and the hydrology and the soil and ultimately the physical form of the landscape itself. The wolf shapes rivers, not with its body, with its presence. Detectives looking at the trophic cascade effects of wolf reintroduction in Yellowstone using long-term monitoring data collected across 2 decades of post-reintroduction recovery revealed the specific sequence of changes with a clarity and a detail that no earlier ecological theory had predicted. The elk retreated from the riverbanks. The willows grew to heights of 4 meters within 5 years in the areas the elk had vacated, heights that had not been achieved for 70 years. The beavers colonized 6 valleys that had had no beavers for decades. The beaver dams raised the water table. The wet meadow expanded. The songbird diversity in the valley bottoms increased. The amphibian populations increased in the newly created pond systems. The fish populations increased in the stabilized, shaded, cooler rivers. And the rivers began to meander. The specific, sinuous, wandering course of a healthy river in a landscape with stable, vegetated banks, the meanders we explored in the slow river script, began to redevelop in the Yellowstone Valley bottoms as the restored riparian vegetation held the banks against erosion and allowed the river's energy to be expressed in lateral movement rather than vertical cutting. 14 wolves, in 9,000 square kilometers of wilderness, changed the rivers. In 20 years, the scale of the intervention relative to the scale of the effect is almost impossible to hold without a comparison. 14 wolves is approximately the number of people who might fill a small meeting room. 9,000 square kilometers is approximately the area of the Canary Islands. The effect on the river hydrology of a mountain landscape the size of the Canary Islands was achieved by the equivalent of a small meeting room full of wolves. This is the leverage of the keystone species. The capacity of a single organism, occupying its correct ecological position, to maintain a system orders of magnitude larger than its own biomass in a specific state of organization and complexity that the system cannot maintain in the absence of that organism. You have experienced this principle in your own social life. The specific person whose presence in a group, in a family, in a team, in an organization, maintains a quality of interaction and a level of function that the group loses when that person is absent. Not because that person performs all the work, because their presence changes the behavior of every other member of the group in ways that produce emergent collective capabilities that the group does not have without them. The keystone person. The one whose removal simplifies the system, whose return enriches it. The wolf is that person, at the scale of an ecosystem. Now consider what the wolf does to the prey it does not kill. The elk that are not caught by the wolves are, in a measurable biological sense, transformed by the attempt. The sustained experience of predation risk, the ongoing awareness of being prey, of inhabiting a landscape where death can arrive from a direction and at a time that cannot always be predicted, produces physiological changes in prey species that are not simply behavioral. They are hormonal, neurological. The chronic low-level stress of living in a landscape where predators operate produces sustained elevations in cortisol and adrenaline that over time affect the immune system, the reproductive system, the metabolic rate, the growth trajectory, and the ultimate size and condition of the individual animal. This is called the landscape of fear. And the landscape of fear is not simply a behavioral state. It is a physical environment, a geography of risk, unevenly distributed across the landscape, with safe zones and danger zones defined not by any physical barrier but by the probability of predator encounter that the wolf's ranging patterns create. The valley bottoms near cover are dangerous. The open ridgelines with long sight lines are safer. The areas the wolf uses frequently are avoided by the elk. The areas the wolf rarely visits are used more heavily. The wolf writes its presence onto the landscape, not in its tracks or its scent marks alone, though both of those are real and persistent, in the distribution of the prey animals, in the pattern of grazing pressure across the vegetation, in the structure of the plant communities that develop in the spaces the prey avoid, in the composition of the soil and the chemistry of the water and the shape of the river channels. The wolf is everywhere in the landscape, even where it is not. Your own presence operates this way in the social landscape you inhabit. The people who know you adjust their behavior in response to their knowledge of you, their understanding of what you value and what you notice and what you respond to. Your absence from a social environment does not leave that environment unchanged. It leaves it without the specific regulatory influence that your presence provides, the specific feedback that your attention and your responses and your history in that group give to the group's behavior. You are a keystone species in your own social ecosystem, as the wolf is in the boreal forest and the mountain valley and the river system that runs differently because the wolf is there. Now follow the pack through a full day, not the dramatic day of the hunt, but the quiet day. The day that constitutes the majority of a wolf's lived experience. The day of movement and rest and play and social maintenance and the patient, unhurried occupation of a known territory. A wolf pack typically travels between 8 and 30 kilometers per day in the course of its normal territorial patrol and foraging activity. 8 to 30 kilometers on foot every day across terrain that includes river crossings and steep slopes and deep snow and the specific obstacles that a wild landscape presents to an animal moving through it. The wolf's efficient ground-covering trot, the gait it uses for sustained travel, not the burst sprint of the pursuit, but the easy, rhythmic, energy-efficient trot that it can maintain for hours, covers approximately 8 kilometers per hour and consumes energy at a rate that the wolf's metabolic efficiency can sustain almost indefinitely. Almost indefinitely. The wolf's cardiovascular system, its heart-to-body weight ratio, its lung capacity, its muscle fiber composition, is tuned for sustained aerobic performance in the way that a marathon runner's is, except that the wolf's physical training began at birth and has been ongoing for 2 million years of evolutionary refinement. The wolf does not tire, not on the time scale of a single day's patrol. It moves through its territory at its easy trot, stopping to investigate scent marks and visual features and the sounds that its enormous ears collect continuously from the surrounding forest, resting briefly in safe, sheltered locations before moving on, covering its territory in a systematic pattern that ensures every significant feature is regularly visited and every boundary is regularly refreshed with a pack's scent marks. It is mapping its world as it moves through it. The same hippocampal place cells that we encountered in the bird migration and the human navigator are firing in the wolf's brain as it moves through its territory. building and updating the spatial map that allows it to know exactly where it is relative to every other significant location in its range, to navigate in the dark, to take efficient routes between known locations, to remember where it cached food and where it last detected prey, and where the boundary with the neighboring packs. Territory runs. The wolf carries its territory in its memory, not as a static map, as a dynamic, continuously updated, three-dimensional representation of a living landscape that is itself continuously changing. The prey moving, the scent marks aging and being refreshed, the vegetation cycling through seasons, the rivers rising and falling, the snow accumulating and melting. The wolf's cognitive map is not a fixed chart. It is a running model of a dynamic system, updated in real time by every piece of sensory information that the wolf's extraordinary perceptual apparatus collects as it moves through the world. Your own cognitive map of the world you inhabit works the same way. Tonight, as the hippocampus replays the day's routes in the fast-forward of sleep consolidation, it is updating that running model, incorporating the day's new information into the existing representation, adjusting the map to reflect what changed, preserving what stayed the same. The wolf and you are both engaged in the same post-day cognitive maintenance, the biological process of integrating new experience into existing knowledge, of updating the mental model of the world with the day's information, of preparing the navigation system for tomorrow's movements through a landscape that will be subtly different from yesterday's. Both of you mapping in the dark. Both of you building toward tomorrow. The pack's territory is quiet tonight. The boundary markers are fresh. The elk are at a safe distance. The cubs from this summer are sleeping in a pile with the adults, their small bodies generating more heat per unit mass than the larger wolves and therefore concentrated at the warm center of the resting pile. The breeding pair are at the edge of the group, their bodies oriented outward as they rest, still monitoring the darkness even in sleep, still performing the specific social role of the parents who hold the knowledge and the boundary and the direction of the pack even in the hours when the pack does not need direction. They are there. They have always been there, at the edge of the darkness, holding the boundary, so that everyone inside it can rest. Your shoulders are already softer than they were when we began. The darkness outside your window is the wolf's darkness. The territory is quiet. The boundary is held. For 10,000 years, we tried to kill every wolf on Earth, not as an isolated cultural phenomenon in one particular region of the world, as a systematic, continent-wide, multi-civilizational campaign of extermination that was conducted simultaneously across Europe, across North America, across Asia, wherever human agricultural civilization expanded into territory that wolves also occupied, and wherever the wolf's predation on livestock represented a direct economic threat to the human communities that depended on those livestock for their survival. The campaign was not irrational. Wolves do kill livestock. They always have. A wolf pack that discovers a flock of sheep without a guardian dog has found the easiest possible meal in its territory. Prey animals that do not run, that do not fight back, that are concentrated in a small area, that provide more calories per unit of hunting effort than any wild prey. The sheep did not evolve with wolves as predators. They did not develop the flight responses, the anti-predator vigilance, the herding behavior under threat that wild ungulates develop over generations of coexistence with a predator. They are, in the context of predator-prey dynamics, defenseless. And the farmer who loses sheep to a wolf pack loses something more than animals. They lose months of feeding and care. They lose the wool and the milk and the future offspring that the dead animals would have produced. In a subsistence economy where the margin between adequate provision and hunger is measured in individual animals, a single wolf attack can represent a catastrophic loss that takes years to recover from. The human decision to kill wolves was, in the context of its time, a reasonable response to a genuine threat. It was also, in the context of the ecosystem, one of the most consequential acts of ecological destruction in human history. In North America, the systematic extermination of wolves began with the arrival of European settlers and accelerated with the expansion of the cattle and sheep ranching industries across the western United States in the late 19th century. The United States government made the extermination of wolves federal policy. Poison, trap, and gunshot campaigns were organized and funded by the government and by the ranching industry. Bounties were paid for wolf carcasses. Professional hunters, wolf killers called wolfers, traveled the western range making their living from the wholesale slaughter of the animal that had been the apex predator of North America for 2 million years. By 1926, the last wolf pack in Yellowstone National Park had been killed. The park, established in 1872 as the world's first national park, set aside precisely for the preservation of its extraordinary natural character, had killed its own wolves as part of the federal predator control program. The irony was invisible to the people who made the decision. The wolves were predators. The predators killed livestock and deer. Killing predators protected the livestock and the deer. The logic was simple, and the science that would have complicated it did not yet exist. The elk population exploded. Without predation pressure, without the landscape of fear that keeps prey animals moving and prevents them from grazing any single location to exhaustion, the elk spread across the valley bottoms and the riverbanks and began the decades-long process of transforming Yellowstone's river corridors from diverse, vegetated, hydrologically complex systems into the simplified, eroded, willow-free landscapes that the post-reintroduction research would document in such careful detail. The rivers changed. The beavers disappeared. The songbirds declined. The fish populations fell. And nobody who was there to watch it happen understood what they were seeing, because the change was slow, incremental, spread across decades, and the baseline they were comparing it to was already a degraded baseline, the memory of what the landscape had looked like before the wolves were removed, already fading from living knowledge into the kind of collective forgetting that happens when the thing that is lost is slow enough in its loss that no single generation experiences the full before and after contrast. This is called shifting baseline syndrome, the ecological phenomenon in which each generation accepts the degraded state of the world they inherit as the normal state, as the baseline against which change is measured, rather than recognizing it as itself a departure from an earlier, richer baseline that the previous generation knew. The forest that the current generation calls pristine was, to the previous generation, already simplified, and to the generation before that, already simplified from what the generation before them had known. The wolf's absence shifted the baseline of what a healthy northern ecosystem looked like, and the absence lasted 70 years in Yellowstone, and much longer elsewhere. In Britain, the last wolf was killed in approximately 1680, more than 300 years ago. The landscape of the British Isles that most people regard as natural, the open moorland, the heather-covered hills, the sheep-grazed upland commons, is not the natural state of those landscapes. It is the degraded state produced by 300 years of unraised herbivore overgrazing in the absence of the predator that would have shaped both the behavior and the distribution of those herbivores. The British uplands without wolves are a ruined landscape wearing the costume of wilderness. Your own sense of what is normal is subject to the same shifting baseline effect. The stress levels that feel ordinary to you, the background level of anxiety and urgency and cognitive load that constitutes the baseline of your daily experience, may be significantly above what a different set of life conditions would establish as normal. The emotional baseline of a life lived in conditions of chronic mild stress shifts, over time, toward accepting that stress as the natural state of things, as the way life is rather than as a departure from the way life could be. The wolf's absence normalized a degraded ecosystem. Chronic stress normalizes a depleted nervous system, both as shifts in the baseline, both invisible from inside them, both revealed only by comparison with a richer baseline, either by the memory of how things were before the loss, or by the experience of recovery. The recovery of the wolf began in the second half of the 20th century, not through any formal program initially, but through the simple fact that the legal protection afforded to wolves by the Endangered Species Act of 1973 in the United States and equivalent legislation in European countries stopped the active killing. The wolf populations that had survived in the most remote corners of their former range, in the wilderness of Minnesota and the forests of Poland and the mountains of Italy and Spain, were no longer being actively exterminated. They were simply left alone. And when a wolf is left alone in a landscape that still contains prey, it does what wolves have done for 2 million years. It disperses. Young wolves leaving their natal pack, typically at 1 to 3 years of age, when the pressure of the pack's social structure and the limited availability of breeding opportunities push the subadults toward dispersal, travel remarkable distances in search of new territory and a mate. Dispersing wolves in North America have been documented traveling over 1,000 kilometers in a single season, crossing state lines, crossing major highways, crossing landscapes that have been extensively modified by human activity, finding the corridors of habitat that remain and moving through them with a navigational precision that modern GPS tracking has revealed in extraordinary detail. Detectives looking at the dispersal routes of wolves from the Yellowstone reintroduction used satellite telemetry to track individual wolves across landscapes that spanned thousands of kilometers and revealed routes of a complexity and efficiency that would have been considered implausible before the technology existed to document them. Wolves that left Yellowstone found their way to the Oregon coast, to California, to Colorado, recolonizing territories that had been wolf-free for decades or centuries, establishing the first packs in those territories in living human memory. The wolf was returning on its own, not waiting for human assistance, not requiring the kind of active management that the 1995 Yellowstone reintroduction represented, simply dispersing, as wolves have always dispersed, into available habitat, and finding, in the landscapes of the late 20th and early 21st century, more available habitat than had existed for the previous century. The catastrophe was not total. The wolf had survived in the margins, and from the margins, it was returning. The recovery of wolf populations in Europe has been similarly remarkable and similarly driven by natural dispersal rather than active reintroduction in most cases. The Italian wolf population, reduced to approximately 100 animals in the remote mountains of Calabria at its lowest point in the 1970s, has expanded to more than 3,000 animals across the Italian peninsula and into France, Switzerland, Germany, Belgium, and the Netherlands. A single wolf species, recovering from the brink of extinction in one small refuge, has recolonized much of Western Europe in 50 years. 3,000 wolves in Western Europe, in a region of approximately 2 million square kilometers, containing a combined human population of approximately 450 million people. The wolf and the human are sharing the landscape again, not without conflict, not without the same fundamental tension that drove the extermination campaigns of the previous 10,000 years. The sheep that are still killed, the livestock farmers who still lose animals and income, the rural communities that still feel, with some justification, that the reintroduction of apex predators into their working landscapes has been decided by people who do not bear the direct economic costs of the decision. These conflicts are real. They are not simple. And the wonder without anxiety reframe that this movement must make is not the reframe of pretending the conflict does not exist. It is the reframe of recognizing that the conflict between the wolf and the human agricultural world is a conflict with a solution that has been implemented in dozens of landscapes across Europe and North America, involving livestock guardian dogs, electric fencing, compensation schemes for livestock losses, and the specific knowledge of how to coexist with a large predator that the cultures of Central Asia and Eastern Europe, where wolves never fully disappeared, have maintained. For centuries. The wolf does not require the extermination of the farmer. The farmer does not require the extermination of the wolf. What both require is the specific institutional and economic infrastructure that allows their coexistence, the compensation payment that replaces the lost sheep, the guardian dog that protects the flock, the land management practice that reduces the exposure of livestock to predation risk. Where that infrastructure has been built, it works. The rivers in the areas where wolves have returned are beginning to change again. Not dramatically. Not in the sweeping 20-year transformation documented in Yellowstone, where the reintroduction produced a density of wolf predation pressure that decades of absence had made more ecologically conspicuous than it will eventually be in a system where prey and predator have reached a new equilibrium. But measurably, the elk and deer and moose populations in the re-wolfeden landscapes of Europe and North America are beginning to exhibit the behavioral changes that predation risk produces. The grazing patterns are shifting. The riverbanks in some locations are beginning to show the early signs of the vegetation recovery that follows the return of predation pressure. The trophic cascade is beginning again. From the margins. Slowly. As the wolf recovers. Your own recovery from the depletion of the day, the specific process of physiological and neurological restoration that tonight's sleep will produce, follows the same pattern as the ecosystem's recovery from the wolf's absence. Not dramatic. Not instant. The first stage is simply the cessation of the depletion, the removal of the demand, the stopping of the cortisol production, the ending of the sympathetic nervous system activation, the downregulation of the arousal systems that have been running at elevated levels since you woke. The baseline begins to restore. And then, slowly, as the night deepens and the sleep consolidates and the restoration systems run their quiet maintenance programs in the dark, the richer state begins to return. The neurotransmitter balances approach their optimal levels. The cellular repair proceeds. The immune system conducts its nightly survey. The memory consolidation builds the specific knowledge structures that tomorrow's navigation will require. The wolf is returning. To the rivers of Yellowstone, to the mountains of Italy, to the forests of Germany, to the ecosystem, to the landscape that was waiting for it, as sleep is returning to you, to the nervous system that is waiting for it. The recovery has always been possible. It just needed the depletion to stop. There is a wolf in your nervous system. Not literally. Not in the sense of genetic material, though your genome does carry, at the deepest levels of its animal heritage, the evolutionary signatures of a lineage that developed its social cognition in the same cold forests and the same cooperative hunting environments that shaped the wolf. In the sense of architecture. In the sense of the specific neural systems that your brain uses to navigate social life, to track relationships, to detect threat and alliance, to read emotional signals from faces and voices and bodies, to feel the specific satisfaction of belonging to a group that is functioning well and the specific discomfort of isolation or social conflict. All of these systems were built for the same purpose that the wolf's pack cognition was built for. Group survival in cold, demanding, cooperative environments. The social brain hypothesis, the theory, now widely accepted in evolutionary biology, that the extraordinary expansion of the primate brain relative to body size was driven primarily by the demands of social living rather than by the demands of ecological complexity, predicts that social cognitive abilities should be the specific cognitive domain in which the human brain is most disproportionately powerful relative to any other species. This is what the data shows. Human social cognition, the capacity to model other minds, to track multiple social relationships simultaneously, to read emotional states from subtle facial cues, to coordinate complex collective actions through communication, to maintain stable cooperative relationships with large numbers of individuals across extended periods, is extraordinary by any comparative standard. No other species approaches the human capacity for the specific forms of social intelligence that group living in variable, resource-limited, cold environments selected for. And the wolf approaches it more closely than almost any other non-primate. Detectives looking at the cognitive abilities of wolves and dogs using comparative cognition tasks revealed something that reframes the relationship between human and wolf intelligence in a way that illuminates both. Wolves outperform dogs on most cognitive tasks that require independent problem-solving, tasks where the animal must figure out a solution to a novel problem without social input. Dogs outperform wolves on tasks that require reading and responding to human social cues, tasks where the animal must follow a human's gaze, interpret a human's pointing gesture, or respond appropriately to a human's emotional expression. The dog gave up some of its independent problem-solving capacity in exchange for social intelligence targeted specifically at humans. 15,000 years of coexistence with humans selected dogs for a version of social cognition finely tuned to the specific signals of a different species, selected them for the capacity to read human faces and gestures and emotional states with an accuracy that no wolf in the wild has any evolutionary reason to develop. The dog became an expert in you, in the specific emotional signals you produce, in the specific facial expressions that carry the most information in human social communication, in the specific patterns of human behavior that predict human intentions. The dog learned to read you the way a wolf reads its pack mates, with the same depth of attention, the same continuous monitoring of social signals, the same responsiveness to the micro-expressions and micro-postures that most humans are not consciously aware they are producing. The dog sees you more clearly than most humans do. And what it reads in you, when it sees you at the end of a long day, when it watches you come through the door carrying the specific posture and the specific facial expression and the specific gait signature of exhaustion, it responds to with a behavior that has no analog in the wolf's social repertoire except in the specific context of the pack member who has returned from a long solo excursion. It greets you, not with the formal dominance and submission signals that characterize the wolf pack's social maintenance rituals, with the specific, whole-body, uninhibited expression of the social animal that is relieved to have the pack member back. The tail, the ears, the forward lean, the eye contact, the vocalization, the specific, unmistakable cross-species signal that says, "You were gone, and now you are here, and the pack is complete again." The dog knows what you are, even if you have forgotten. You are a pack animal, a social mammal that evolved in cooperative groups and that carries, in every system of its biology and its psychology, the evidence of that evolutionary history. The specific pleasure of social connection, the neurochemical response to positive social interaction, the oxytocin release, the dopamine signal of social reward, the cortisol reduction that physical proximity to trusted individuals produces, all of it is the wolf pack's biology, expressed in a primate nervous system that developed the same capacities for the same fundamental reasons. Your social needs are not cultural constructions or personal preferences. They are biological requirements, as fundamental to your functioning as the wolf's need for pack membership is to its own. The wolf that is separated from its pack does not simply become lonely in the colloquial sense. It becomes physiologically compromised. Its cortisol levels rise, its immune function declines, its behavior becomes less efficient, its survival probability decreases. The isolation is not merely unpleasant. It is harmful in the specific, measurable, biological sense of producing outcomes that decrease the organism's ability to function. Your social isolation produces the same effects, for the same reasons. Because you and the wolf are both organisms whose biology was designed for a specific social environment. The small, known, stable, cooperative group of individuals who share territory and resources and the specific, warm, mutually dependent social bonds that make cooperation possible, and whose physiological systems register the absence of that environment as a form of stress that they were not built to sustain indefinitely. You need your pack, as the wolf needs its. Tonight, wherever the people who constitute your pack are, sleeping in the same building, sleeping in other buildings across the city, sleeping in other cities or other countries or on the other side of the world, you are connected to them through the social bonds that the day's interactions have maintained and that the night's separation has temporarily suspended. The connection is not broken by the physical distance. It is preserved in the neural representations of those relationships that your social brain maintains continuously, in the specific patterns of firing that encode the identity and the history and the emotional significance of every person who matters to you and that are active, even now, in the background of the cognitive activity that is beginning to slow towards sleep. Your pack is with you, even in the dark, even in the silence. Detectives looking at the sleep behavior of the grey wolf in the field, using GPS telemetry and biologgers attached to collared wolves that recorded movement, heart rate, and activity level continuously, revealed something about the pack's sleeping behavior that recalibrated the understanding of how wolves manage the tension between individual rest and collective vigilance. When a wolf pack rests, the members do not all sleep simultaneously. They stagger their sleep in overlapping shifts, some sleeping while others remain in a light vigilance state, monitoring the environment, ready to rouse the sleeping members if a threat is detected. The pack stands watch for itself, not through any formal assignment of roles. Through the natural variation in sleep depth and arousal threshold that exists between individuals in any social group, the variation that means some members will always be lighter sleepers, more easily roused, more likely to be monitoring at any given moment. The pack's collective vigilance emerges from the sum of its individual sleep patterns in the same way that the pack's collective intelligence emerges from the sum of its individual cognitive assessments. No one wolf is responsible for keeping watch. All the wolves are, through the same distributed, collective, emergent architecture that runs every other aspect of pack cognition. Your social brain maintains a version of this collective vigil even as you approach sleep. The neural systems that monitor for social threat, that track the emotional states of the people around you, that maintain the boundary of the social group against intrusion, that monitor the relationship network for the signs of conflict or disconnection that require attention, these systems down-regulate more slowly than the cognitive systems that process explicit thought. They remain active, in the lighter stages of sleep, longer into the night than the systems of waking consciousness. You are still watching over your pack while you sleep, at a reduced level, in the background, in the way that the lightest sleeping wolf in the pile is still monitoring while the others sleep deeply, not fully awake, not fully asleep, hovering in the specific state of social vigilance that the pack animal maintains even when it is most at rest. It is enough. The pack is safe tonight. Let the vigil relax. If this journey into the life of the wolf has been useful to you tonight, if this hour of pack intelligence and trophic cascades and the wolf's long catastrophe and its extraordinary recovery, and the recognition that your own social brain was built by the same evolutionary pressures that built the wolf's, has helped the day's social navigation settle into the quiet that the night provides, then I would gently invite you to subscribe or to leave a thought below about which part of this stayed with you longest. Whether it was the 14 wolves that changed the rivers of Yellowstone, or the dog that evolved a facial expression specifically to communicate with you, or the wolf lying down at 2 in the morning in the boreal forest with its ears still turning in the dark. It helps other pack members find their way here, other social mammals lying in their own warm dark, also feeling the day's social effort release into the specific, ancient, pack animal comfort of the group at rest. One howl at a time. And if sleep is still arriving slowly, if the pack's collective vigil is still running at a higher level than tonight requires, there is another journey waiting. Another apex predator. Another ancient social system. Another piece of the deep biology that connects the living world to the nervous system you are lying in right now. Told at this same unhurried pace, in this same quiet voice. It will be there when you need it. But for now, feel the weight of your body where it meets the surface beneath you. The surface holds the whole weight, completely, without adjustment, the way the frozen ground holds the wolf pack in their resting pile. Not requiring anything, not asking anything, simply receiving what is placed on it. Allow your shoulders to soften now. The way the wolf releases its body into the pile, not collapsing, not abandoning the vigilance entirely, just releasing the muscular tension that activity requires, settling into the warmth of the bodies around it, allowing the shared heat of the group to supplement the heat of its own metabolism. You are in the pile now. The pack is together. The territory is quiet. Allow your jaw to unclench. Allow your hands to open. Allow the thoughts that are still circling the perimeter of your attention, still performing the social monitoring, still tracking the day's unresolved interactions, still holding the pack's concerns at the surface of awareness, to do what the lightest sleeping wolf does in the depths of the night. Slow down. Space out. Find the long quiet intervals between one thought and the next that are the threshold of sleep. Tonight, somewhere in the dark outside a city you have never visited, a wolf is listening. It has heard the forest. It has decided that what it heard is nothing. It lies down, and the pack, arranged in their pile of shared warmth, breathes together in the cold dark of the boreal forest, each member's breath visible in the frozen air, each member's warmth contributing to the warmth of all, each enormous pair of ears still turning slightly in the dark, still receiving the forest's acoustic information, still performing the lightest level of the collective vigil. But slower now. Quieter. The forest is safe. The territory is held. The pack is together. You are the pack. You have always been the pack. In the dark. In the warmth. Together. Nothing needs guarding tonight. The territory is quiet. Let the ears relax. Let the vigil soften. Let the warmth of the pile hold you. Sleep well, and good night.